Students, in this video I will explain Charles law, Boyle's law and the other variables with all the characteristics of gas you learn. So here the Charles Boyle has given the idea studies that the relation of volume with pressure at constant temperature. Charles what done? Charles see that pressure remaining constant, okay, P remain constant for in case of Charles, okay, and with increased temperature he has seen that volume also increasing, with increased temperature. Suppose there is a particular gas is present, pressure is constant, I am not providing any pressure on it. So if you increase the temperature, its volume will increase. That is the simple thing discovered by the, that is the simple thing, okay. Charles has seen that pressure remaining constant, the volume of a given mass and dry gas must be, you have to retain, is directly proportional to its temperature. So V proportional to T is equal to, if you just emit that proportionality sign, equal to, there will be a constant come. So V is equal to KT, V by T is equal to K. If two condition gas has taken, okay, same gas suppose taken in two different condition, T at temperature T1 volume V1, same gas at temperature T2 volume V2, both is constant, that means V by T, V1 by T1 is equal to V2 by T2, this will be equal to this, and that is the simple thing. If the Charles law and mathematical expression will be there, you need to write this, and you will get the full mark, okay. So I think you understand that what Charles studies, the temperature volume relationship of gas, okay, that is the temperature volume relationship TV, and Boyle PV, pressure volume, okay. Now students, come to the graph. In graphical representation you can see of the Charles law that volume and temperature right side, with increased temperature volume also increase, that's why directly the graph will come like this, and at 0 degree, at 0 degree centigrade you can see the curve, the straight line will start from here. Why student not from here? Because volume, you can see that is the volume, here means some volume is present, okay. I am putting some value, suppose that is 10, 20, 30, 40, suppose milliliter volume has given, suppose 10 milliliter or 20, means at 0 degree centigrade, 0 degree centigrade volume will never zero, that is centigrade, volume will zero at absolute zero. Absolute zero means 0 Kelvin or minus 273 degree centigrade, that is, which is never a gas will reach to this temperature, because before in practical, before minus 273 degree centigrade a gas liquefy or solidify, or if a gas converted into liquid or solid, why it will follow gas laws? Charles and Boyle's laws to applied only for gas. So if a gas will converted into liquid or solid, it will not follow the Charles law or Boyle's law, whatever the gas law. So I hope, so I think you understand. That's why the graph is started from here, and it is increasing as temperature increasing, volume increasing. So graph will be like this, and at 0 degree centigrade, the 0 degree centigrade, the gas has some volume. That's why from 20 ml we have started, okay. And if you increase that graph backside, you can say at minus 273 degree centigrade it will mix with the temperature, means temperature 0, volume will be 0, okay. In this point, particular point means temperature minus 273 degree centigrade and volume will be 0, here means this is the volume from above below volume, that means volume is 0 at minus 273. I hope students you can draw the graph. So here little bit explanation of the scale, Celsius scale and Kelvin scale. A Kelvin scale, the 0 degree of Celsius scale is equal to 273 Kelvin, degree centigrade, Kelvin is equal to degree centigrade plus 273. So 0 degree centigrade is equal to 273 Kelvin. So 100 degree centigrade is equal to 373 Kelvin. So if you 0 Kelvin, absolute 0 means is equal to, it will be minus 273 degree centigrade. 0 will be minus 2, because you see 0 273, that will be minus 273, it will be 0, okay. So means 1 Kelvin is equal to 1 centigrade. Here you can see 100 gap, 273 to 373, similarly 0 to 100 degree also 100 gap. So 1 Kelvin is equal to 1 centigrade, we will convert when 0 Kelvin is equal to minus 273 degree centigrade. So the temperature minus 273 is called absolute zero. Okay, the scale with its 0 at minus 273 degree centigrade and each degree equal to the 1 degree of Celsius scale. You can see 1 Kelvin is equal to 1 degree Celsius is called absolute or Kelvin scale. So what is the definition of Kelvin scale also you get from here. Okay, you just read this, then you can easily understand, and why it will not valid, that minus 273 really actually practically not achieved. Theoretically though it can be, you can establish any formula with by using rules or laws, but practically it should be happens, but here practically it is not takes place. Student, this is all about the Charles law. Charles law and the numericals, you need to check some numericals related to the Charles law. All numerical come by using this formula. I am showing you some your book page. There the examples you must practice 5 6. Okay, you can see V1 T1 V2 T2 at, suppose here, at what temperature will 500 centimeter cube of a gas measured at 20 degree centigrade, means volume and temperature has given, temperature will be converted into Kelvin scale first. Okay, occupy half its volume, half means divide by 2 means V2 will be 250, temperature will be that. Okay, X. You can not write like this. Okay, 270 plus T, if you not write P, it will be okay, because at the end also you can convert it also, convert it, can you can convert into Kelvin. Okay, otherwise it will be good, no problem student, you do like this. Okay, it will be easy. If that let the temperature T degree, you add with 273 and convert all degree centigrade into Kelvin. Okay, otherwise the math will be not considered, because all in the numericals of gas all temperature will be measured in Kelvin. Okay, so some numericals is present here, I will solve this and I will provide another video with Boyle's law numericals and Charles law numerical. Now student, I am explaining the gas equation. Okay, very easy, the combination of Charles and Boyle's law. Here I am explaining Charles and Boyle's law gas equation. Charles means the calculating the change of volume of a gas when pressure and temperature both change simultaneously. Okay, when temperature change, here you know temperature constant and here pressure constant. Temperature constant means V varies 1 by P, pressure constant means V varies T. Okay, so combine two you get V varies T by P. That means if you just remove that proportionality sign, you get KT by P or PV by T is equal to K. So that is the combination. Okay, means change of volume of a gas, temp or volume, pressure, volume and temperature, three variable together is constant. So if you take two condition P1 V1 by T1, another P2 V2 by T2, P3 V3 by T3, whatever the you will take, that all will become as constant. Okay, so that is the combined gas equation, and from that combined gas equation numericals will come. So one video will be there for the numericals, three numericals or all numerical. If I can't solve, means I can't provide, maybe the video will be longer. So three from Charles, 3 Boyles and 3 with the gas equation I will provide in another lecture. Thank you.